Book Impressions, The Art of Doing Science and Engineering by Richard Hamming, Part 3. This is the section that I title A Bit from It. So the question is about the purpose of mathematics. And he talks about the different approaches of mathematics, the formalists like Filbert that start with assumptions and then just generate truth based on logical operations, the Intuitionists that start with an intuition and then sort of derive logical truth out of, basically starting with the goal and try to explain the goal. And there's other explanations for the purpose of mathematics. But I think once you go through this chapter in the book, and also after reading many approaches towards trying to explain what mathematics is and what the purpose of mathematics is, I think the way I see it is that the purpose of mathematics is to explain nature. So what we experiment in nature, what we see, the experience we gather from interacting with nature, then has to be formally explained somehow or formally put down in a language, and that's mathematics. So mathematics is the language by which we try to explain what we see in nature. Now, having said that, there's some people, let's say Demis Hassabis from DeepMind, who once said, and I thought that was interesting, that mathematics is conducive for physics, but neural nets are more conducive for biological systems. And what he means with that is that complexity arising from biological systems is difficult to explain mathematics. Now, I disagree with that because I think the problem is not the mathematics is not well suited for biological systems. In fact, biological systems are physical systems like any other physical systems. It's just that we don't have the mathematics that are necessary to explain things like biological systems or just generally experience with nature, which are biological systems in a sense. So now neural nets are a hack, like they're function approximators, because we don't have the mathematics. We can now approximate functions, so we can approximate cause and effect, through artificial neural nets, and that's certainly one of the biggest advancements in the last 20 years, is to develop large neural nets, deep neural nets, and reinforcement learning to deal with the problem of interaction with nature and how to actually formalize that and how to engineer it into systems that can be useful. That's where we stand right now. But as far as this conversation is concerned, I think the purpose of mathematics is to explain nature. Therefore, I think pure mathematics is an oxymoron. It's not worth studying. It's the wrong thing to do. I think mathematics always has to be studied in the context of physics, and maybe increasingly now AI, because AI is morphing into physics. Like AI is nothing but a more sophisticated mathematical tool to explain physics. Let me elaborate a little bit what I mean with that. So I think we're now in a sort of air pocket of AI where language is all the rage. We can, write Shakespeare poems, or we can prompt Shakespeare poems to be more precise. And we can do a lot of things. We can code. We can do a lot of nice things with AI that is language-based. But that's just a footnote given the actual endeavor humans are involved in over the long run, which is dealing with nature, understanding nature, taking advantage of nature, harnessing nature, particularly energy. So those kinds of problems require a new set of mathematics, and that new set of mathematics will come from exposing ourselves to nature. Now that means that we have to gather the right data first and foremost to learn. Whether we learn it through So whether we learn this from experiments in the lab or whether we learn it in a world model, or it doesn't really matter. But the idea is the following: like anything which is conducive to learning will eventually be conquered by an intelligence, whether it's biological or artificial, doesn't matter. Intelligence is in principle the same thing. Now, The difference between biological and artificial intelligence is that artificial intelligence has a lot more energy and available to it, and it also can iterate at much higher scales and speeds. Now, biological intelligence has certain advantages too. It's incredibly efficient and stuff, but I think in the long run, intelligence will be, it's kind of like flight. I mean, birds are not really what we think about when we say flight. When we talk about aerospace or flight or things like that, we talk about rockets, we talk about fighter jets. I think our ingenuity to engineer intelligence will way quantum leap biological intelligence. So what I'm trying to say is that intelligence will eventually be mainly measured in what we call today artificial intelligence. So that kind of intelligence will allow us to get much more insights into nature and scratch the surface in much deeper ways. And just to give a few examples of what I mean with that. For example, we have no idea right now about how particles interact. We have some ideas, but we really are struggling to understand the fundamental interactions between particles. I think if we can find ways to industrially gather data and learn from the data, whether it's through cameras or whether it's through other types of sensors, we will develop much more insights into the interactions of nature. The same applies to biology, let's say drug discovery and human bodies and things like that. But again, everything hinges on the, whether it's conducive for learning or not, hinges on the availability of data, the desire to collect the data in the right way, to store it in the right way, and to make it machine learnable, because that's what intelligence will look like in the future. So to answer the initial question and to sort of finish the loop here between my thoughts and the book discussions in Richard Hemming's book, I think the purpose of mathematics is to explain nature. That's it. It's very simple. And the more truthful it is, the better. But, where there is rigor, meaning disappears, and where there's meaning and rigor disappears. So we can't be too obsessed about either meaning or rigor. We have to find a middle way. And that is probably the most ingenious thing that humans can do, which is to thread this fine line between, okay, look, it's not super clear, it's not 100% true, but it helps me explain certain things in nature that help me interact with nature, which maybe has some economic value, or maybe it just helps me from not being destroyed by an asteroid. Thank you.